A mass m is suspended from the two coupled spring connected in series. We know that in a series, equivalent force constant is given by 1 upon k is equals to 1 upon k1 plus 1 upon k2. What they are saying, a mass m is suspended from the two coupled spring connected in series. The force constant of springs are k1 and k2. The time period of the suspended mass will be, it is a problem from 1990 AIPMT. So, for both springs, combined k we can calculate by this. It is k1 plus k2 by k1 k2. So, what is the equivalent force constant? It is k1 k2 upon k1 plus k2. What is the formula for spring? Time period is 2 pi under root m upon k. In place of k we have to put this. So, what we are getting? 2 pi under root m upon k. K means k1 k2 upon k1 plus k2. Take it in numerator. So, what we are getting, which is written in D option. 12th, a body of mass 5 kg hangs from a spring and oscillates with a time period of 2 pi. If the ball is removed, means body is removed, the length of the spring will decrease by. It is a problem from 1994. We know that what restoring force is acting on the spring, it is minus kx. Minus means opposite direction. It is balanced by the weight of your object, your body. So, what is x? If you remove this, it will be back by this amount. So, in this way, you can easily get this. What is given in this? Mass is 5 kg. With a time period of 2 pi second. What they are given? Time period of 2 pi second. Time period was given 2 pi. We know that t is equals to 2 pi root over m by k. So, t is equals to 2 pi mass is 5 by k, cancel this 2 pi with 2 pi. So, you will get k is equals to 5. So, 5x is equals to 5g. So, it means the spring will back by a length which should be equal to g meters. So, we are going with D option. Next problem is from 1998 AIPMT. A mass m is vertically suspended from a spring of negligible mass. The system oscillates with a frequency n. What will be the frequency of the system if a mass 4m is suspended from the same spring? We know the formula for time period. It is 2 pi root over m upon k. Remember, it is formula for time period. First, we have to make the formula for frequency, which is the reciprocal of time period. So, it should be 1 upon 2 pi root over k by m. This. Now, what is happening there? Initially, frequency was n. It was the initial case. What we did now, frequency is changed. Why? 2 pi is same constant. Spring is same, so same force constant we are using. In place of m, we put 4m. It is the cause for changing of frequency. So what we are getting from 4 take 2 outside. All previous quantities except this 2, it means it is old frequency. So we are getting old frequency divided by 2. So n dash should be n by 2. So we are going with option B. Next, a mass m is suspended separately by two different springs of spring constant K1, K2, given the time period T1 and T2 respectively. If same mass m is connected by both springs as shown in figure, the time period T is given by, what is the formula for time period? T is equals to 2 pi root over m by k. We know that this is parallel case. In parallel, equivalent force constant, spring constant is given by k is equals to k1 plus k2. So first, we put first mass on first spring, we are getting time period T1. So T1 was 2 pi under root m upon k1. Then second mass T2, we use second spring for same mass. So we will get 2 pi under root m by k2. Now springs are combined. So T should be 2 pi, T3 should be 2 pi. And now they are saying T, not T3, they are saying T. So we are writing T, 2 pi under root, mass is same. For combined spring, K should be K1 plus K2. Mass is same, so we will use that concept. By squaring the equations, what we are getting? We will use this relation, K is equals to K1 plus K2. We can use this also. T1 is T1 square is equals to 4 pi square m by K1. T2 square is equals to 4 pi square m by K2. T square is equals to 4 pi square m by K1 plus K2. See, what is 1 upon T1 square plus 1 upon T2 square? It is K1 upon 4 pi square m1 m plus K2 upon 4 pi square m, means it is K1, it is K2, it is K2. So what we are getting? K1 plus K2 upon 4 pi square m, which is the value of 1 upon T square. It is a value of 1 upon T square. So what we are getting? We can write in this way, T raised to the power minus 2 is equals to T1 raised to the power minus 2 plus T2 raised to the power minus 2. So we are going with option D. 15th problem. The time period of mass suspended from a spring is T. If the spring is cut into 4 equal parts and the same mass is suspended from one of the parts, then the new time period will be, it is a problem from 2003 AIPMT. I told you if you are cutting in spring in n equal parts, force constant, spring constant will become n times. if initially spring constant was K, you are cutting in 4 parts, so each part has now spring constant 4K. So what they are saying, initially time period was T when you are using full spring M by K. Now time period is changed because you are using same mass with one of the part. So it should be now 4K. Take 2 outside. So what we are getting, only this 1 upon 2 is extra. All other terms are previous one. So for them we can replace this by T. So what we are getting now, T by 2. So we are going with option C. Two springs of spring constant K1 and K2 are joined in series. The effective spring constant of the combination is given by I told you, for series equivalent spring constant is given by this formula. For parallel, K is equals to K1 plus K2. So take LCM. What we are getting, K1 K2 K1 plus K2. So K should be equal to K1 K2 upon K1 plus K2. So we are going with option D. Next, a mass of 2 kg is put on a flat pan attached to a vertical spring fixed on the ground as shown in the figure. The mass of the spring and the pan is negligible. When pressed slightly and released, the mass executes a simple harmonic motion. The spring constant is 200 Newton per meter. What should be the minimum amplitude of the motion so that the mass gets attached from the pan? So what will happen in this case? The force when you are pressing, the spring will resist by the force, we know that K into X. It is balanced by mg. So it means X you will get from the formula mg divided by K. What is M? M was 2 kg. What was G? G is 10. What is spring constant? 200. All things are given in SI units, so we will get in meter. If you want your answer in centimeter, it is 1 upon 10 meter or 100 upon 10 centimeter. So what we are getting? X should be equal to 10 centimeter. X should be equal to 10 centimeter. Next problem is from 1993 AIPMT. A body executes simple harmonic motion with an amplitude A. At what displacement from the mean position? The potential energy of the body 1/4 of its total energy. We have complete derivation before starting the crash course problems. What is the formula for potential energy? Half m omega square y square. It was the formula for potential energy. What was the formula for kinetic energy? No need, but you should know kinetic energy was half m omega square a square minus y square, and total energy was half m omega square a square. What they are saying, at what distance, at what value of y, potential energy is 1/4 of the total energy. Means potential energy should be 1/4 of total energy. means total energy half m omega square a square. It should be 1/4 of half m omega square a square. But formula for potential energy is half m omega square y square. It should be equal to 1/4 1/2 m omega square a square. So, what we are getting? Cancel m and omega square and this 2. So, what we are getting? Y square is amplitude square by 4. So, y should be a by 2. They are given a is capital A. So, we will go with capital A by 2, means option B we will go. Next problem. A loaded vertical spring executes SHM with a time period of 4 seconds. The difference between the kinetic energy and potential energy of this system varies with a period of, I told you, in one cycle, frequency of kinetic energy and potential energy is twice. It is twice in one cycle. So, what should we do? The time period of simple pendulum is, the time period of this spring is 4 seconds. Its frequency is 4 seconds and kinetic energy and potential energy, their difference is twice. It is making maximum and minimum. So, 2 times in one cycle. So, its time period should be 2 seconds. After every 2 seconds, it will give same value. So, we are going with C, 2 seconds. Next, it is from 1995 AIPMT. In a simple harmonic motion, when the displacement is 1/2 of the amplitude, what fraction of the total energy that was kinetic? First, what is the formula for kinetic energy? It is half m omega square a square minus y square. What is the formula of total energy? Half m omega square a square. We are talking about a displacement 1/2 of the amplitude. When y was a by 2, what was the kinetic energy? Kinetic energy was half m omega square a square minus y square, means a square by 4. So, what we are getting? Half m omega square into 3a square by 4. What fraction it is of total energy? Means we have to divide kinetic energy by total energy. So, what we will get? Half m omega square 3a square by 4 in numerator. What is in denominator? Half m omega square a square. Cancel half with half. M omega square with m omega square. A square with a square. So, what we are getting? We are getting 3 by 4. So, we are going with option D. We are going with option D. Next, a linear harmonic oscillator of force constant 2 into 10 to the power 6 Newton per meter times and amplitude 0.01 meter has a total mechanical energy of 160 joules. It's, what should we do? What is the formula for potential energy? We know that for a spring, potential energy is half kx square. Everything is given half. What is K? 2 into 10 to the power 6 Newton per meter. And what is amplitude? Amplitude is 0.01. 0.01 means 1 upon 100 into 1 upon 100. What we are getting? Potential energy should be 100 joule. So we are going with option C. So we are going with option C for 21st. 22nd. It is from 1991 AIPMT. The angular velocity and the amplitude of a simple pendulum is omega and A. Omega and A. At a displacement x from the mean position, if its kinetic energy is T and potential energy is V, then the ratio of T and V is, we know the formula. What was the formula? Potential energy half m to y they are denoting by x. What is the formula? It is for kinetic energy. Formula for kinetic energy. What is the formula for potential energy? Half m omega square x square. Kinetic energy they are saying T. Potential energy they are saying V. The ratio of T upon V means half m omega square A square minus x square in a numerator, V half m omega square x square, in denominator cancel half m omega square. What we are getting? A square minus x square by x square. So we are going with C. 23rd. A simple pendulum is suspended from the roof of a trolley which moves in a horizontal direction with an acceleration A. The time period T is given by this. G is equal to C. Now at your bob of simple pendulum, it will experience two accelerations, one due to trolley's motion, another due to gravity. Both are vector quantities, so resultant should be root of A square plus G square. We know the vector addition, so it means G will replace by root of A square plus G square. So we will go with D option. 24th. A second pendulum is mounted in a rocket. Its period of oscillation will decrease. I told you that T is equals to in general 2 pi root L by G. But if rocket is moving with acceleration A in upward direction, it will become 2 pi root over L upon G plus A. But if it is going in downward direction, it will become 2 pi root, like lift problem, G minus A. If T is decreasing, means denominator should be increasing. So what is the case? It is the case of this, ki rocket is moving with an acceleration in upward direction. So moving up with uniform acceleration, we should go with D. So 24th D. 25th. If the length of a simple pendulum is increased by 2%, then the time period, means we want to calculate what is relation between T and L. T is proportional to root L. Means if we are changing only length, T upon root L should be constant. what we want to calculate, by what percent t will change. If we are increasing the length of pendulum, t is directly proportional to length. If L is increasing, t will increase, so cancel these two. By what amount means new time period minus old divided by old into 100. We want to calculate this. We want to calculate t dash by t minus 1 into 100. It is our target function. Now, take initial length 100. So, t by root 100. Final, we are taking t dash. The length of pendulum is increased by 2%. So, it is now 102. What is t dash by t? Under root 102 by 100. We will use binomial. It is very important tool for you. Write 100 to 100 plus 2. If first term is 1, second is less than 1, you can multiply the power with the second term, ignoring the next terms which have higher powers. So 1 plus, it will become 1 upon 100. Multiply 1 by 2 with this. So t dash upon t, we got 1 plus 1 upon 100. So what we are getting? 1 upon 100 into 100 means 1. So we will go with increase by 1%, B option.